Hello everybody. Today we're on lesson 96 and it's a really long lesson. I apologize for that, but there's 7 examples, so it might take me a couple of videos to get them in. We'll see how it goes. So if you look on page 492, derivatives and integrals of functions that have absolute values. If you look at the graph that they have there, the graph of y equals sine of x. You know that it goes like this, and then it would be like this on the other side. So when you take the absolute value of it, everything that is below the x-axis is just going to pop up here. Okay, so we could define this function, the derivative of it. Remember, that's the derivative of the tangent line. We can define it. Remember, right here, it comes down like this. So there's not going to be a derivative at this point because that's a cusp. But when it's going to be equal to, so here, when x is positive, or when sine of x is positive, so all of these, when sine of x is positive, the derivative is just going to be cosine of x. And that's when sine x is greater than 0. At 0 itself, it's going to be undefined. And then when sine x is negative, then it would be minus cosine of x. All right, so that's the derivative. So in general, there's a formula that you can use. The derivative of the absolute value of a function of x is going to be equal to f of x divided by absolute value of f of x times the derivative of the function, of the original function. And you can see that that works for this one, for sine of x, because this value right here would be the f of x over absolute value of f of x would be a -1 times that. So it does work. We don't actually have to use it in this lesson or very often because we're going to be looking at these things graphically. So the first one we're going to do is to let y equal e to the absolute value of x. Find dy dx. So if we look at the graph of this thing, it means we're never going to be plugging in a negative number. Well, we'll never be raising it to a negative exponent. We'll be plugging in negative numbers for x, but we won't ever be raising it to a negative exponent. So e to the 0 is 1, and then it increases like, oops, sorry, that was bad. iPad slipped. So it looks something like this. And then if you take y to the negative x, not the absolute value of that, but y to the negative x, it would be over here like this. So the derivative when x is greater than 0 is just going to be the same as it would be for e to the x. So when x is greater than 0, the derivative, actually we can do x is greater than or equal to 0 because it is defined there, of e to the x is e to the x. But when x is less than 0, it's going to be e to the negative x, because we're plugging in a negative number for x here. The graph looks the same, it's just reflected here against the y-axis. So if we look at the derivative of this absolute value function, now we have, let's see, we would break it up into 2 pieces. So y would be equal to e to the x when x is greater than or equal to 0, and e to the negative x when x is less than 0. So then the derivative when x is greater than or 0 is just e to the x. But the derivative of e to the negative x would be minus e to the minus x. So what happens is that we can, now if we look at that right there, negative e to the minus x would actually be down here at negative 1. It's an open dot because we didn't include 0 there, but it would go like this. And then e to the positive x would be up here like this. So does the derivative exist at x equals 0? No, so we can't define it at x equals 0. We simply have to say that this right here is true when x is greater than or equal to 0, and this is true when x is, sorry about that, it should be x not equal to, just x greater than, because it doesn't exist at that point. So this would be when x is less than 0. So, okay. All right, let's go on to one that's a little bit easier than this one. It says, let f of x equal cosine of the absolute value of 2x. Find the derivative of x, of f of x. So let's think about this, guys. Is cosine an even or an odd function? If you plug in a negative x right here, cosine of negative 2x without the absolute value, cosine of negative 2x is the same as cosine of 2x, isn't it? So really we don't even have to think about the absolute value part of it, because it's the same whether it's negative or positive, because it's an even function. So if you determine that you have an even function, the absolute value is not going to be affected. It doesn't just apply to cosine. So we can just go ahead and take the derivative of this. So that would be negative 2 sine of 2x. All right? That was not too bad because it's an even function. If it's not an even function, then you have to break up the graph and look at it in pieces. Okay, the next one is the integral from negative 3 to positive 3 of the absolute value of x plus 1 dx. Okay, well we got to think about this graph. This is just a graph of a line. It's a simple graph. X plus 1 means it starts here, has a slope of 1, so it's just going to go like this. The original line without the absolute value would be like this, right? And by taking the absolute value, it's just going to flip. Anything that was there is going to go above the x-axis instead. So from here to here, we have this, and we're only going to 1, 2, 3. So we're only talking about this little piece here. And this one goes to 1, 2, 3. So we're talking about this piece here. So when we integrate, remember the definition of the integral is the area bounded by the curve and the x-axis. So the areas that are above the x-axis are the ones that I'm showing you right now. All of these. But we can't just integrate it just like this. We're going to have to break it up into an integral from here to here and then from here to here. It's not a hard integral to evaluate. It's just that you have to look at the graph in order to determine how this has to be set up. So we're going to take the integral from negative 3 to negative 1 of x plus 1. And we're going to take, and that'll have to be the opposite of it because it ordinarily would have been down here, correct? So we have to multiply that by a negative and then add the rest of it, which is from negative 1 to 3 of x plus 1. And please don't forget the dx in here. Some of you have gotten really sloppy about that on your tests. I haven't been taking off, but I'm going to have to start doing so because when you get into your next calculus class, your teacher won't be as friendly as I have been if you forget that differential in the integral. All right, so when we integrate this, what do we get? We're going to get minus x squared over 2 plus x evaluated from -3 to -1 plus x squared. Oh, this minus x squared, that should be a minus, sorry. Got to distribute that negative right here. Okay, so that's minus x squared over 2 minus x. All right, and then this one will just be x squared over 2 plus x evaluated from -1 to 3. Okay, so now then what are we going to get? Let's see, that'll be minus, a minus 1 squared would be minus 1/2, and that would be plus 1, and then minus, plug in -3 will be minus 9/2 plus 3. And then over here we get, that would be 9 over 2 plus 3, and then minus, plug in -1 would be minus 1/2, minus, plug in -1 will be a -1 here. So that would simplify to what? That's a plus 1 and a minus. So that's a plus 1 and a plus 1. So we've got -9/2 plus 9/2 plus 9/2 is 18/2. 18/2 minus 1/2 is 17/2 minus 16/2, so that would be positive 8. And then what else do we have? We have minus 1, minus 3. That's minus, that was minus 1, so that's a plus. Sorry, I can't read my own writing. 1 minus 3 would be minus 2. Minus 2 plus 3 is 1. And 1 plus 1 is 2, so 8 plus 2 is 10. All right, so the integral of this function right here is equal to 10. All right, let's move on to the next one. This is at the bottom of page 494, 96.4, and it says evaluate the integral from -pi/2 to 0 of sine of absolute value of 2x dx. All right, well, let's look at the graph of this, okay? It's sine of 2x, not just sine of x. Okay, so ordinarily it would be up, down, whatever, right? Keeps going. And back here, since we're at -pi/2, it'd be like this. Okay, and the only difference is that here is pi/2 instead of 1 pi, and this will be -pi/2. And this is still 1, -1. All right, so if we take the absolute value of it, this guy just flips upside down. And of course these do too, but we're only talking about we're talking about this area right here. Let's see. So we know that the sine of 2x is equal to sine of -2x, right? These are the same. So then we're just going to have the integral from -pi/2 to 0 of sine of absolute value of 2x is equal to the integral from -pi/2 to 0 of sine of -2x dx. So then we can use a u substitution, and we'll get, let's see. We say that u is equal to negative 2x, then du would be equal to minus 2 dx. So we'll have to have the integral, we'll have negative 1/2 out in front of sine of u, which will be and the sine of u, that's du. So then we would end up with the integral of sine is negative cosine, so it'd be and then that's evaluated from negative pi over 2 to 0. Oops. I just went ahead and changed it back from the u here and made it easier to work with. All right, so then if we plug it in, we're going to get 1/2 looking at this. This was negative 1/2 because u was negative 2x. So negative 1/2, we didn't have a negative. We pulled out the negative 1/2, and then this will be the integral of sine of u. The integral of sine of u is negative, but then times this again will make it positive. And then it will be cosine of which will give us 1/2 cosine of 0. And then minus cosine of 2 times that would be positive pi. And then we've got 0 and pi. Cosine of 0 is 1. Minus cosine of pi is negative 1. So 1/2 of 1 plus 1 is 1/2 of 2, which is equal to 1. All right, next one. This one is actually even easier because it's the integral from negative pi to positive pi. Oops. Negative pi to positive pi of the absolute value of sine of x. So if we look at the graph of that, without the absolute value would be like this. This would be negative pi, this would be positive pi. So when this flips back up, it's like this, isn't it? So really the area, the integral of this would be 2 of these, or 2 of these, but it's easier to work with this one. So what we can do is we can just say the integral will be the same as the 2 times the integral from 0 to pi of sine of x dx. So then the integral of sine would be negative cosine, so minus 2 cosine of x evaluated from 0 to pi. And that would just be negative 2 times cosine pi minus cosine 0, which is what we got in the last one. So it would be negative 2 times pi would be minus 1, and minus that would be minus 1. So then minus 2 times minus 2 would be positive 4. Okay, a couple more. This one, f of x equals the absolute value of sine of x minus 3/4. Okay, so remember, that's the graph of sine of x just shifted down 3/4 units. So if you look at the graph at the bottom of page 495, sine would ordinarily be up here, but it's shifted down here to negative 3/4. And then it shows you where it crosses in here. So it goes something like this. And then it comes down here, down, and then back up. And it would do the same thing on the other side. So it crosses here, it goes down like this, and then it comes up. And it shows you that this would actually be, what is it? 1 minus 7/4, 3/4, so another 4/4 would be, this would be 1/4. And this is down here is negative 7/4. It says to find the maximum value of f. Now remember, this is the absolute value, so everything that's down below has to go up here. Up here. So if this